Hey y'all, let's talk about just an introduction to Euler paths. I want to do some practice problems with you, and I'll post a couple of videos because while this unit isn't hard or difficult, it's very accessible for everybody. If you didn't come to class or you didn't Zoom with us or didn't pay attention, it might be completely and totally confusing and looks a little bit scary. So I just have this graph here, okay? And it says for the following graph, what is the degree of each vertex? So first off, the vertices, the vertices are just the points that are labeled with the letters. So like A, B, C, D, E, and F, those are all of our vertices. And when it's asking us for the degree of each, it's asking us to count how many lines kind of are going out of each vertice. Okay, so let's start with A, and my pen isn't writing. I'll write a different color. So for A, if we look right here, you've got 1, 2 lines going out of A. So if you were with us in class or paid attention in Zoom, a lot of times Mr. Dietz would write a 2 and he'd kind of circle that there. So we can put a 2. For B, you've got 1, 2, 3 coming out of B. C has just 1. Oh, I didn't put 1. Okay, D has 1, 2. E has 1, 2, and 3. And then F. This is one of the more commonly missed kinds of questions. So F right here has what we call a loop. So it comes right back around to itself. So technically, we're going to count this as 1, this is 1, and this is 1. All right, so it counts twice here for the loop itself. So the degree of F is actually going to be 3. If there was a question here that asked you to find kind of like, how does it word it? It's like something like the total or the sum of all of these, we would just add it all up. So 2, 3, 1, that gives us 4, and 2 is 6, and 2 is 8, and 6 is 14. So like the total for all of the vertices would be 14. Part B is asking us to find all the circuits. So let's review what a circuit is. So a circuit has to start and end at the same vertice. All right. So you have to be able to leave and then come back to it. Let me see if I can find my eraser. Kind of without picking up your pen, if you will. And that's kind of how we started in our exploration activity. Now, there's a difference in an Euler circuit and then this just asking us for a circuit. So for just a circuit, for instance, I could start here at B, right? And I could go B to D to E to B, all right? So if I wanted to write that, I could write B, D, E, B. So we went 1, 2, 3. Okay. And if it asked for the length here for that, the length of that circuit would be, it's going to be 1 less than the number of letters. So we have 1, 2, 3, 4 letters. So the length of this circuit will actually be 3 because we're counting the number of lines or the number of edges that we've traveled down. And another thing, when you're kind of writing out the letters, you're naming your circuits, you've got to end and start with the same letter. So even though some people were writing B, D, E, and then just kind of stopping, you've got to come back to B. And then I think, technically here, this loop could be a circuit. So let's see, we're starting at F, we're looping back around and we're ending at F. I don't see why that wouldn't be. So F, F, and the length there, the length is going to be 1. I don't see any other way you could start and end at a vertice and then make it back to where you were without crossing over a part that you've already been down. So for part C, it says find the longest path between any 2 vertices. The longest path between any 2 vertices. So let's see. Naturally, it looks like C and F are kind of the furthest apart, so I'm going to erase. This is why you don't do these kinds of questions in pen, because they are tricky sometimes. Okay, so if we're talking about the path, the longest path between any 2 vertices, we from C to A, that's 1, A to B, that's 2. Sorry, I'm writing with a highlighter. Then if we go B to D, that's 3. D to E, that's 4. E to F, that's 5. And I guess you could probably go from F back to F there and get 6. So if we're writing it out, it might look a little strange. We went from C to A to B to D to E to F. Ooh, sorry, that looks a little weird. D to E to F. I guess we might not include the loop there because we've already reached F, so there's no reason to really loop back around to it. So I'm actually going to erase that instead of just making an entirely new video. And then you would be, if we're counting how long that is, the length of it, or the longest path between any 2 vertices, we've traveled 1, 2, 3, 4, 5 different edges. And we do 6 letters, so it makes sense that our length is 5 because that's 1 less than 6. If we're listing the edges that are adjacent to vertex A, that's going to be any vertice that not any vertice, any edge that includes, or any vertice, sorry. The edges or